In electrical networks, a parasitic element is a circuit element. It could be either resistance, inductance, or capacitance that is possessed by an electrical component but which is not desirable for it to have for its intended purpose. For instance, a resistor is designed to possess a resistance, but it will also have unwanted parasitic capacitance. There are two types of parasitic resistance. They are series resistance and shunt resistance. Let us discuss what is series resistance. The total resistance of resistors in a series is equal to the sum of their individual resistances. R total is equal to R1 plus R2 and so on. Series resistance in a solar cell has three causes. They are: the first cause is the movement of current passing through the emitter and the base of the solar cell. The second cause is the contact resistance between the metal contact and the silicon. Lastly, the resistance of the top and rear metal contacts. The main impact of series resistance is to reduce the fill factor, although excessively high values may also reduce the short circuit current. The IV chart clearly indicates that the current flow through the cell is affected by series resistance, but at the same time, open circuit voltage is not affected. The solar cell is not affected much in series resistance. Shunt resistance. Current shunt resistors are low resistance precision resistors used to measure AC or DC electrical currents by the voltage drop those currents create across the resistance. Sometimes called an ammeter shunt, it is a type of current sensor. In electronics, a shunt is a device which allows electric current to pass around another point in the circuit by creating a low resistance path. In solar modules, the significant power losses caused by the presence of a shunt resistance RSH are typically due to manufacturing defects rather than poor solar cell design. The IV chart shown here explains that the low shunt resistance causes power losses in solar cells by providing an alternate current path for the light generated current. Such a diversion reduces the amount of current flowing through the solar cell junction and reduces the voltage from the solar cell. The effect of a shunt resistance is particularly severe at low light levels since there will be less light generated current.